rate in calories per minute at which a person using a treadmill burns calories is modeled by the function f, given by f of t, which is equal to negative 1/4 t cubed plus 3/2 t squared minus 1 for values of t greater than or equal to 0, but less than or equal to 4. The person repeats the exercise but adds arm movements that burn an additional 3 calories per minute for the duration of the workout. Right? The new function representing the number of calories per minute for the treadmill exercise with the arm movements. So first off, take a look and just kind of digest the information, make sure you understand what's going on, identify the independent and dependent variables, and when you've done that, go ahead and press play again. Alright, hopefully you didn't get too caught up in imagining someone using a treadmill without arm movement. That could get a little confusing. Hopefully you made it past that. And if you did, you should have identified the independent variable as time, in minutes, and the dependent variable as calories burned per minute. And this is important because it might be easy to think, oh, okay, this is a certain time, and given that time, this is how many calories I burned, and it's not. It's very clear that the rate in calories per minute is given by f. Okay, so f is calories per minute. So at a certain time, how many calories am I burning per minute? Okay, that's the question that I am being asked, or the situation I'm being given. And so the question then becomes, all right, when I add in these additional arm movements, I'm burning an additional 3 calories per minute for the duration of the workout. So let's just think about this situation here. Now I want you to envision the situation. What would make up the new total calories per minute? Hopefully you've come to a conclusion that, so let's say we're writing a new function, okay, our new function f of t, and what's going to go into making the total number of calories I'm burning per minute? Well, there's two components. The first component is the calories per minute without the arm movements. So we'll use green to denote that. That's the calories per minute without arm movements. Okay. Plus, I use a different color here. The calories per minute from the arm movements exclusively. So remember, this is everything but arm movement. And the red here, these calories per minute, are from arm movement only. Right? So now we have this idea, okay, what's the number of calories I'm burning per minute without the arm movement? And then let me add on, in addition, the calories I'm burning per minute due to the arm movement exclusively. And now that we have this conceptual idea of what's happening, I only need to put in the pieces and figure out what they represent. So let's think about the calories that I'm burning per minute, the rate at which I'm burning calories without arm movement. Where do I get that? So I want you to identify that and then press play. Hopefully you realized that our original function right here gives us the number of calories I'm burning per minute, okay, at any given time. So I can actually input that into my equation. So negative 1/4 t cubed plus 3/2 t squared plus 1. All right, I'll just box that in green again so we remember what that is contributing to. And now I simply have to think about what is going to represent the number of calories I'm burning per minute from arm movements only. So I want you to identify that, try and represent it as an expression, and then we'll come back and we'll check. All right, so hopefully you noticed that you're burning an additional 3 calories per minute for the duration of the workout. So we want to think very carefully about how to implement this. Okay, so the person repeats the exercise but adds arm movements that burn an additional 3 calories per minute. So let's think about how this would play out. Let's say without the arm movements, you are burning 4 calories per minute at time 1 or whatever it is. Okay? If you add in the arm movements, how many calories should you be burning per minute at that time? Think carefully. What you should come to the conclusion is okay, if I burn 4 calories per minute without the arm movements, I should be burning an additional 3, so I should add 3. Now you want to be careful, it might be tempting to say that I'm burning 3 times t, but that's incorrect because really all we're doing is adding an additional 3 to however many I was burning before. The arm swing isn't varying with time, it's simply being added on. Once again, think of the situation where if you were burning 4 calories per minute, but then you added in the arm swing, how many calories per minute should you be burning? Well, the answer would be 7 calories per minute. And so we can see that this is going to be a constant term, and if I go ahead and simplify this out, my new expression is going to be -1/4 t cubed plus 3/2 t squared plus 4. And that's going to be my new expression, which includes the arm movements. Again, things to be mindful of are the fact that we are measuring calories per minute, and so when I am increasing the calories per minute by 3, remember I'm not increasing it every minute, it's simply adding on to the rate. So if my calories per minute were 4 calories per minute, now it's going to be 7 calories per minute. Hope that helped.